All right, guys, welcome to another CyberSec Tuesday. Tonight we got Magus, aka John, doing a talk on DNS. Always to blame for all the problems, and he's going to tell you why.
Absolutely. Thanks for the introduction there, Sinek. I appreciate it. It's good to be back on Null 404 presenting myself as opposed to just running things behind the scenes. Hi, everybody. Today, as Sean said, we're going to be talking about DNS. So, DNS is a very simple but very, very important um, system that is used for all kinds of fun things across the internet. So, what is DNS? DNS stands for Domain Name System. Okay? It is a series of tools and servers that essentially act as the phone book and translator that changes things from human readable addresses to IP addresses. Because computers don't think in human readable addresses, they think in a bunch of series of numbers. You probably have seen a lot of things in your home network, like 192.168.1.1, or there's all kinds of stuff, 208.46. Blah, 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 blah. It is impossible for most people to remember that Google might be this IP address. So we rely on the domain name system, or DNS, to translate google.com into that IP address. So how does DNS work? Well, there are four main parts of DNS. The first thing you have is your recursor. So the recursor, let's think about the domain name system like a giant library. The recursor is the librarian who goes, when you ask, to find the book that you're looking for. Your recursor can live locally on your machine. It can be a server that is hosted by an enterprise, or more commonly these days, at least for personal use, a recursor will be a web service that you use that acts for you. So a lot of the ones that you'll probably hear about commonly as recursors are things like 1.1.1.1 at Cloudflare, 8.8.8.8 for Google, etc. So that's what a recursor does. A recursor is the machine that does the initial translation from a human readable address, and it goes to look for what the IP address is in its great catalog. Now, the way the catalog works is a sort of a three-step domain, okay? The first thing that you have is going to be a root name server. So that's the first step. Once the recursor gets the mission to go and figure out where google.com is, the first person that it asks, if it doesn't have it stored locally, is a root name server, okay? So it's like the big index, right? Like the card catalog, if you will, for continuing our library thought process that hosts all the different types of TLDs. So a TLD is a top level domain. So that's your .coms, your .govs, your .aus. Those are all TLDs, and the root name server is responsible for that big TLD organization stuff. Once it determines that, hey, yes, google.com, we're going to be going to .com, it'll then point you to the TLD, or top level domain name server. So that's like, continuing the library analogy, that's like the rack of books. So, the card catalog for, at the root name server said, hey, go to this shelf. All right. And the shelf, breaking down the shelf, or the shelf itself is your top level domain. So that's the next step. And once you're at the TLD, it'll be able to categorize things into specific categories, if you will. So again, .com, .gov. Like once you're in .com, you go to your TLD. Now to actually find Google, TLD then points you to what's called an authoritative name server. And the authoritative name server is the actual dictionary or book that you're looking for. It is the place that knows that google.com is let's say 208.46.53.156. So that is a basic breakdown of how DNS operates across the internet. You have your recursor, which is like the big find it. A recursor first goes to the root name server, which then goes to the TLD name server, which then goes to the authoritative name server to find the website that you're looking for. So a recursor is also known as a DNS resolver. It recursively looks at these servers, which is where it gets its name, to determine the IP address from the human readable address. Now that we have a basic understanding of how DNS works, we're going to do some very fun, cool things that you can set up for yourself in the home lab. So, as I said, a recursor or a DNS resolver can be hosted either locally or on an enterprise server, or most people use a service recursor such as Cloudflare or Google. I don't like any of that. I like doing everything myself. So within my home lab, I have my own DNS resolver, my own recursor, in the form of Unbound. So Unbound is a completely self-contained recursive DNS system. And we are going to use my fancy handy-dandy Raspberry Pi that I have just plugged into my network for this talk to go through setting that up. Any questions so far? Any comments? No? Cool. Awesome. All right. So, using your own DNS offers you a lot of cool advantages. You're not dependent upon dependent upon any other server. You can do everything self-contained. You control everything, and you can set up a lot of cool things like DNSSEC or DNS over HTTPS, which allows sort of encrypted traffic of what your DNS lookups are. And why that can be potentially important is because a lot of times your internet service provider will be looking at your DNS traffic, or it may automatically set your system's DNS to its own DNS name servers, so that they can see, for whatever reason, whether it be advertising, etc., what it is that you're doing on the internet. And I, working in cybersecurity, am extremely paranoid, hate everybody looking at my internet traffic, so I just don't want to have to deal with any of that. I'd rather do it myself. So we're going to use Unbound, as I said. First things first, I don't know, last time, oh goodness, I have touched this thing, so I'm going to go sudo apt update and then sudo apt upgrade. I'll make sure I'm, oh, yeah, of course it needs to be done. That's what happens when you do things live. Oh my goodness, please hurry up. In the meantime, actually, you were saying something earlier there, next sortie, about questions that you ask people about DNS. Do you have any that I didn't cover?
Yeah, so like usually during my interviews that I'll ask people just to kind of start the conversation when it involves network traffic forensics. One of the ones I kick off with is talk to me about DNS.
Mm-hmm.
And a lot of the questions can range from, it kind of takes people by surprise, like what do you mean DNS? And questions range from it links IPs to URLs. It does all the way to, I don't know, but it works on port 53. All the way to, it starts off on your host system, it checks the host INI file, then it goes to your router, then your ISP, and all the way up to the authoritative name server. And those questions, when I'm talking to someone like that, immediately kind of gives me clue, like, oh, they know exactly the whole process, all the different handshakes, and I know that they know a lot about DNS, which excites me.
Awesome. Cool. Perfect timing, just in time for this to finish updating. All right, to get started with installing Unbound, we're going to go ahead and do ye olde sudo apt install Unbound, tac y, so it doesn't ask me a million questions. All right, so it is now installed. Once we have it installed, the first thing that we're going to do is we're going to go into the configuration file. By default, gosh, I hope my notes are correct. It should be here. Ah! Love it. Love to see it. And there are normally a whole bunch of things that should be here, but okay. I'm going to go ahead and copy and paste them because, you know, I'm awesome. Yes, here. All right, so we're going to be setting up a bunch of stuff, and I'm going to walk through what all this means within your configuration file. So we're setting some server rules because this will be setting up a DNS server. That's what it is, a recursive DNS server on your device. So we are telling it that is going to be on interface 0.0.0.0, so that's looking at itself. It's going to be broadcasting on port 5335. My preference is for IPv4 and not IPv6, so we set yes and no here. We want it to handle both UDP and TCP traffic. This is going to be this is for me, this is within my network. This is going to be what your gateway address is, so or gateway network is. So for me, my network is 10.100.0.0 for my general management network. And then I have some additional things here. So I have enabled DNSSEC, which is, as I mentioned before, what it does is it validates via certificates that the IP address that you are getting is in fact actually the web address that you want to go to. There is a form of attack that can take place where the IP of within the DNS ecosystem, IP address for a website is changed to a malicious address. And so what DNSSEC allows you to do is to validate via certificates that the IP address that you are receiving is in fact the accurate and confirmed IP address of the website that you want to go to. And then we have some just cache stuff, and we are going to go ahead and write this out and close. And that's really about it that we need to do within the configuration. So we're going to go ahead and do some checks to make sure that I didn't mess up. My configuration file. There's fortunately an auto tool that does that, so we don't have any errors with Unbound check conf. We're going to go ahead and make sure that the Unbound service is restarted, so it takes on the new configuration commands. We're going to do systems control enable so that it starts on system startup. And then we're going to do a check here. We're going to go ahead and do a net stat check to make sure that the service is actually running on our system. And we can see, indeed, there is. Both in TCP and UDP, there is a service running on port 5335 of our own device. So, hooray! We have our whole DNS resolver in the form of Unbound setup. And it is set up with DNSSEC, and it's nice and happy and secure. We can confirm that we are using DNSSEC, actually, by see if DNS utils is actually included already. If it's not, we'll make sure it's done. No. We can, do a dig command, dig at ourselves. 5335. sectools.org. And we're looking, of course. So you can see, let me expand this a little bit, make it a little easier. So what we did with this command is we were running the dig command. We told it to use our device as the DNS resolver at port 5335, and we went to dnssectool.org. We told it to look for the A DNS record, and we made sure that it had the DNS flags included. And as you can see, the resolve came back with AD, which is a flag that you're primarily looking for. But also, it's very easy to tell that you were running DNSSEC because, look, you have this wonderful DNS certificate and key saying this is, in fact, the accurate place that you're going to. So cool. We know Unbound is operating correctly. Well, what does that do for us? Well, as I said, it gives us our own resolver, but that's really not a whole lot of fun. So there's a tool that I like to include in my own DNS configuration. Some of you may or may not have heard of it. It is called AdGuard Home. Now, AdGuard Home is a competitor for the very famous Pi-hole, which is sort of like your own local DNS management tool. It's just a personal preference for me that I like AdGuard Home versus Pi-hole, but if you like Pi-hole, you can do that too. So let's go ahead and start setting up AdGuard Home. That is a really long command, so I'm just going to copy and paste this instead of typing. And by the way, all of these notes will be available for you guys at the end of this. I'm not just going to leave you hanging. And this is just us gathering AdGuard Home and installing it. And it looks like I already had it installed. Yep, cool, sweet, awesome. Okay, let's see if this will work. Hypothetically, it should automatically be running. What is my... Thanks, that's very good. Yeah, awesome, wonderful. Well, let's see this. By default, it should be running on port 3000. Aha, it is. So, to make sure that the web server so AdGuard is a series of tools, but the configuration, the human configuration is available on a web server. So I just went to localhost and then the port that it defaults to, which is 3000 for the setup. So we can go ahead and set all of this up. So here's the important part, listen interfaces. What we're going to do is we're going to set this to our one that we just set up. So I want it to listen to itself on port 5335. Listen bind address already in use. Oh. What? Why just do this? Oh, look.
I was going to say you're doing it live, so the demo
Yeah,
gods will...
man, gotta love doing it live. All right, I'm just gonna click next and see what happens. We're gonna make ourselves an extremely strong password. Oh God, administrator. And this is broken. Why? All right. Well, this isn't going to work. Sure. But at least I can show you the interface. And then I can show it you running on my actual system. No, never. Go away. All right. So what we have allegedly set this up to do is it is going to be looking for our DNS resolver. Normally you would set it up with, you know, your Cloudflare 1.1.1.1, but since we are able to, we've set up our own recursive resolver, we've pointed this to look at the Unbound resolver that we've just set up. What you do from here then is set up your network to look at this for DNS. So since we have this running, I am going to go ahead and change what I have here. Let me open up a new window. Actually, I could probably just do it from here. No, oh no, I don't remember what the freaking address is. Bam. So, this is AdGuard Home. As you can see, it tracks a whole lot of really cool metrics, such as all of your queries, all of your filtered stuff, any rules you have going on, all of the device clients and what they're looking up, all of this wonderful, wonderful, great data that I love so much. What makes this very cool is that there are a lot of built-in block lists that you can download and utilize for DNS filtering to stop things like ads and other potentially hostile websites that you may incidentally visit by clicking a malicious link, etc. It will just stop the lookup at the DNS level before any HTTP traffic is ever transferred, and it will just kill it dead on the spot. It'll send that request to a black hole. And I love that. I think that's really cool. The other thing that you can do is that AdGuard Home incorporates a bunch of services. So let's say that I am running this at home and my wife is annoying me, so I'm going to say, hey, you're not allowed to use TikTok anymore. Or my son can't play Roblox. Or, whatever it may be. LinkedIn is evil, so I got rid of it. I can set all of these filters so that any attempts to go to any of their domains or any of their sub-addresses will fail. It just blocks them too. And it's toggleable on and off, which is super cool. And all of my systems point to this for their... I can actually show you. Hopefully there's nothing too crazy that I'm going to show off in my network here. Aside from my WAN IP. Yeah, I don't mind that. Settings, networks, show options. Yep. So via my router, I use Unify. I have pointed to my DNS server as that AdGuard setup, and it shoots it out via DHCP to any system that is connecting to my network, so that every single one knows to go to AdGuard. The other thing that you can do, and as you probably saw from like my address here, Megos Forge, is DNS rewrites. So this is one of the things that is used at enterprise a lot with DNS, which is DNS rewrites. That is creating web addresses for internally hosted services. So as you can see, these 10.100 addresses would be in RFC address space. They're not publicly accessible, so a normal DNS recursor would not be able to find them. So you create these DNS rewrites within your system to say, hey, I want these addresses to go to these IPs. And that is pretty much it. It's super straightforward and is an incredibly powerful tool for you to control your network. Any questions?
I got a question.
Send it.
So you're going to go over Pi-hole next, right?
Nope, I was not. I don't use Pi-hole.
Okay.
I use AdGuard instead of it.
Okay, so like overall, I haven't really used either of them, but I've been curious. What do you say? Why would you like AdGuard or so over
The same
Pi-hole?
reason that I preferred OpenSense over PFSense. It's all about the user interface, man.
Okay.
Yep.
No, like specific
They
features?
both do effectively the same things. The only features that I've seen AdGuard Home have that Pi-hole doesn't, and this may have changed since the last time I used Pi-hole, is the toggleable blocked services tool. But otherwise, they act the same. They're a DNS management tool that you can use for your network to do things like rewrites, filtering, etc. They're equivalent in terms of their what they actually do at the programming level.
And AdGuard, correct me if I'm wrong, it's open source as well too, right?
Yep, sure is. So it is, all of their code is available on GitHub for review, and it's sourced from GitHub for download.
Nice. Okay, cool. Thanks, Vegas.
Yeah, absolutely. So who wants to set this up in their home lab?
So I will say I used AdGuard before I just deployed Ubiquiti equipment, and I actually thoroughly enjoyed AdGuard. Now again, I could redeploy AdGuard and repoint it and stuff. I'm just using Ubiquiti's native tools. Big fan of AdGuard if anyone is considering switching to it. Lots of cool features, and they do a lot of interesting things too. I would say if I was going to rate the ad blocking capability of AdGuard versus Ubiquiti, I'm finding AdGuard to be better as your DNS solution for that purpose over Ubiquiti's equipment native DNS solution for that.
Yep. So as you saw, I do run Ubiquiti, their ecosystem at home. I prefer running my DNS independently, utilizing Unbound as a recursive DNS and AdGuard versus their integrated tools, because a lot of the security functionality that you can implement in Unbound, like DNS over HTTPS, some of their DNS sec functionality, and then the granularity and block lists available in AdGuard versus Ubiquiti's integrated services, that's why I run it the way I do. And as you can see, I need to update. But I don't want to do that now, because then I'll be kicked off the internet. All right. Anybody have any last words?
Did you go over how to force everybody on your network to go through that?
Yes. So the way that you would do that is via your router's DHCP. So for those who don't know what DHCP is, Dynamic Host Controller Protocol. It is what your router tells every device that connects to the network what their gateway is for reaching the internet, what their DNS server is, and a whole bunch of other important information like that. Within Unify, you would go to your network setup stuff and utilize their DHCP service management things to point your DNS to whatever it is. Now, how you actually do that will be different from service to service. If you're using ISP given equipment, you may not have the ability to do that. But if you're using tools like OpenSense, pfSense, Ubiquiti, Meraki, you name it, you would absolutely have the functionality to assign your DNS server both for the gateway itself and to give that address to the clients via DHCP.
Sweet.
Mm-hmm.
Anybody here running anything similar on their network at all? Or using any sort of DNS tools at all?
Well, you should be, and now you know how to.
Well, I will say this. There is a really cool tool. If you wanted to upgrade your home lab, let me say this, or even a workplace. John, go to Rita, RITA. This is an amazing tool that was open sourced by Active Countermeasures, Black Hills Information Center, Chris Breton, which I should probably shout him out because he came here, did a talk on this. This is a free tool they released. There's a long story. If you scroll up to the picture, that's actually John Strad's mother, who passed away, who would actually do red team activities with him. If you guys don't know the whole story with that, super cool. And as she unfortunately passed away from cancer, and he has a really emotional story. And as he was doing this proprietary tool, he named it after her, which is what Real Threat Intelligence is. Her actual name was Rita, which is how they got the name. And from that tool, she wanted to like help organizations become more secure, and he open sourced Rita after patenting it. So there's like 6 patents for the algorithm that's used. That any organization can open source this tool, by the way. So even commercial, business, personal use, you can download this tool, you can deploy it in a Docker, and what this will do is actually detect beacons coming outside of your network based on the DNS it's going to. And it to be frank, it just works.
Yep.
So highly recommend active countermeasures. If you don't do any of their training, they do training like every quarter where they actually go over how to deploy this tool. And if you don't know how to deploy this tool, just ask one of us, because I think I deployed it in my network. But an amazing tool that just works. Highly recommend it. It's open source. Look it up. We should probably do another talk on it. I can't do every year. We should do a talk on just Rita alone. But
yeah, as a matter of fact, what I'd like to do, I think would be a cool add-on or a part 2 to this is, so Rita is dependent upon Zeek, or if you want to be insane, PCAPs to operate. So enabling logging and transfer of syslog of, say your Unbound or AdGuard instance to Zeek, and then exporting that into Rita could be a whole thing we could do. But not today.
Well, I'm losing my voice here. Are you able to talk on any of the encrypted DNS options out there at all?
So you're talking about like DNS over HTTPS or TLS?
Yeah, or one of the different flavors of it.
So yeah, so DNS, there are a number of secure methods. So that would be an encrypted tunnel that you're reaching out to your native servers with. You could use DNS over HTTPS / DNS over TLS. Essentially, it utilizes the security protocols inherent in HTTPS / TLS to create an encrypted tunnel from your recursor to the name servers, right? So much like if you were going to your bank's website, when you're logging in, it'll be an HTTPS TLS secured connection. As you're entering all of your username and password and such like that, that's an identical connection that your recursor is making to the name servers. So very identical handshakes, TLS handshakes, everything all the same. Is there anything specific you wanted to know about it?
No, I just wanted the info shared with the community.
Mm-hmm.
A lot of folks might not be aware
so
of it.
within the configuration file that I set up within Unbound, enabling DNS over HTTPS was one of the things I do. It'll be in the list of commands that I'm going to drop before I forget about it in Meetup text right now. It's incorporated into the configuration file along with DNSSEC. So that it both encrypts the actual traffic in a TLS tunnel, as well as uses DNSSEC to verify that the IP address that you are getting is secure. Let me drop these into text.
Did you cover authoritative name servers, like from where your system or where
how it gets there?
AdGuard gets theirs?
So going back to our explanation that we had in the beginning, we set up our recursor, so our DNS resolver. Instead of using a local using a hosted service like Cloudflare or DNS, what we did is we set up Unbound with AdGuard filtering on top of it. So this is now acting as your recursor at home. What it does is it will when you initially type in a request, it'll first look to see if it has that information in its cache. If it does not, if you've never visited that site before, it'll follow the path of going from the root name server to the TLD name server to the authoritative name server.
Yeah, I'll point out just some to the folks too that there are some cool alternatives outside of Cloudflare and Google DNS. There's also Next DNS that's out there. Next DNS is one that I use personally. It's kind of cool. It's very configurable. Supports TTPS over DNS and the like. As well as what's the really other? What's the Quad
Quad
9?
nines, yeah.
Yeah, Cloud Nines is another one that's like supposed to be a privacy focused one. There's a lot of these resolvers that are out there that claim to not log, claim to have additional privacy features, things like that. So those are other things to consider. There's two things to consider when you look at the resolvers. You got speed, which is a big one. I think Cloudflare and Google are probably the fastest out there. And then there's privacy, which is Quad 9. Cloudflare I know is really popular in privacy as well too, and a bunch of other options. And a lot of them have different features like DNSSEC and blocking malicious domains. Some are configurable like NextDNS and things like that. And the cool thing too is a lot those resolvers and those settings can also be downloaded to your phone. So if you have an Android phone, there's a private DNS setting on the Android phone where you can actually point to one of those solutions out there like Cloudflare or Quad9 or the like, as well as there are profiles you can download for iPhone that are open, and you can actually have that. So all your traffic on your iPhone, for example, would be routed over, DNS over HTTPS or whatnot. I'll drop some links in the channel on that.
Heck yeah. I will say though, for me, nothing beats doing it at home.
Yeah, I guess the only thing is you'll need to
Mobile
have
devices for cell stuff. Yeah.
Yeah, if you have like a VPN maybe back home.
I got a question kind of piggybacking off of that. So I guess part one of the question, how does Unbound keep itself updated? Because I imagine IP addresses can change somewhat frequently.
Yes.
And then can you set like Quad 9 as like a backup if it doesn't know where to look?
Yes. There is... Okay. Okay, so within a resolver, there is published by... Gosh, I can't remember it off the name of my head. Let me look it up real quick. I think it's IANA. IANA is domain space people, right? Yes, Internet Assigned Numbers Authority. So they release a series of what is called help files that is used by recursors like Unbound or whatever, big scale stuff that's doing to help the recursor find those tools. Unbound has a built-in process to keep that up to date, as well as its cache. It will check to, your cache has a limited lifetime. So you set a time to live category. So, if it's within, I don't know, say 72 hours, it'll just assume that that IP address it has is correct. If it doesn't work, then it'll follow the recursive pattern of going through all of the name servers again. But generally speaking, yeah, that's how it works. It uses the IANA's helper files to go to the root name servers and keeps that up to date based on a TTL setting. Did that answer your question?
Gotcha. Thanks. Yeah, it did. Thank you.
Okay. Well, cool. If that covers everybody's questions, I'm going to go ahead and wrap this up. Going once? Going
Yeah,
twice.
no, 100%. We'll cut the stream. And again, I just want to thank our partners. ArcLight 6 is our partner who is greatly assisting us keep the lights on. And actually, if you do some of our cybersecurity CTFs, they are sponsoring certifications for those to get broken into the field. So again, thanks to ArcLight 6. John, go ahead and close it up.
All right. Well, hey, thanks everybody for attending. I greatly appreciate you giving me your attention, and I hope you all have a great evening.